Okay, so this is your review for Unit 8. Just make sure you check over all your answers, make sure that you understand everything. We've been reviewing for a few days now, so this is just kind of an extra reinforcement. It can never ever hurt to take an extra review sheet and do this again. You should do each review sheet at least twice. Okay, there is a test tomorrow. I know I'm not in school today, but there is a test tomorrow. I will be in school tomorrow. And you better be as well, taking the test. All right, so why don't we look at the first group on the first page. Okay, they all refer to the question up at the top or the graph up at the top. So here we're looking at as x approaches -4, but only from the negative direction, which means from the left-hand side. So here's -4. From the left-hand side would be this graph, this piece of the graph. And you can see that that just keeps going further up and up and up and up and up and up and up. Okay, so what y value does that approach? That approaches infinity. All right, now we look at the same question, but this time we're coming from the positive direction. So here is -4. Coming from the positive direction would be this portion of the graph right here. And we can see that the y value that it approaches is -2. So then, therefore, remember that when we don't see a little plus or minus sign to the right of a number, that wants you, in this case, it wants you to look at the limit coming from the left and the limit coming from the right. And do they approach the same number? Which certainly they do not. So in this case, then our answer is D and E. Okay, so I'm going to repeat that one more time. When there's no little, oops, hold on a second there. When there's no little plus or minus sign, where am I? Here we go. Sorry, I needed my little pointer. When there's no little plus or minus sign after the number, to the right of the number, we look at the limit coming from the left and the limit coming from the right. Since these aren't the same, it's D and E. If, for example, both of these were like a -5, then my answer would be -5, but that's not the case here. All right, so let's look at number 4. We are approaching -2, but we are coming from the negative direction. So let's find -2. From the negative direction is this part of the graph, and you can see it's going toward a y value of 1. So our answer there is 1. If we look at number 5, same value, except coming from the right-hand side. So again, here's -2. Coming from the right-hand side, that is going also toward a 1. Okay, so what I was just saying then is if you compare these two right here, the limit coming from the left is not the same as the limit coming from the right. So therefore, our answer here is D and E. Now I know that there is no question that refers to the limit as x approaches -2 altogether, but if I had a limit of the function as x approaches -2, and in this case, there is no plus or minus here, then what I need to do is look at the limit from the left and the limit from the right. And in this case, they are approaching the same number, so my answer is 1. Okay? All right, let's go to number 6. Here, no plus or minus, so you've got to look coming from the left of 3 and from the right of 3. So here's 3. Well, coming from the left and coming from the right approaches that same y value, and that y value is 3. F of 1 is not a limit. It's just asking when x is 1, what's the y value? So let's go to 1. Now I have something here and I have something here, but this is an open circle, so there's no y value there. So you just go to where there is a y value, and that would be 1. And the last one, number 8, we want to know what f of -4 is, similar to number 7. So we have an x value that's -4, and we want to know what its y value is. But if you look here at -4, There's no y value here. This just keeps going on forever and ever. And there's no y value here either, because that's an open circle. Okay, so in this case, it does not exist. Don't say undefined, because undefined means like 1 over 0, or 3 over 0, or negative 8 over 0. DNE means there isn't a value, and that's the appropriate answer. All right, so if we turn the page, let's look at number 9. And it says to evaluate the following limits. And it says right here that we are evaluating as x approaches 2. In this instance, since there's no plus or minus after here, we need to look at the limit coming from the left and the limit coming from the right. Now look at these domains here. This is the limit coming from the left because it has numbers that are less than 2. And this is the limit coming from the right because that encompasses numbers that are greater than 2. So we have to plug it into both parts, and let's see if we get the same answer or we don't get the same answer. So we're going to plug in 2 to the top. And when I say we plug it in, we're plugging it in right here. So I'm plugging in 2 minus 1, which is 1. Now I'm going to do the same thing down here. I'm going to get 2 times 2 minus 3, which is also 1. So these guys right here are the same. So in that case, you've got your limit from the left is equal to your limit from the right. These guys are equal. Let me get my pen back up here. In that case then, the limit of the function as x approaches 2 would be 1. That would be your answer. All right, so let's look at 10. Same deal again. We don't have a plus or minus after here, so we have to look at the limit coming from the left as well as the limit coming from the right. I am going to plug in what? I'm going to plug in 1 now, right? So 4 in here, I'm going to plug in a 1 here and do 4 minus 1 squared, which is going to be a 3. And then here, I'm going to plug in a 1, and that's going to give me a 2. So you should see that my limit from the left doesn't equal my limit from the right. So then your limit of your function as x approaches 1 would be DNE, doesn't exist, because the limit coming from the left doesn't equal the limit coming from the right. All right, now number 11, what it wants you to do is it wants you to look at this function f of x right here, and it wants you to find out, in this case, what's f of negative 2, and what's then after that, what's f of negative 1, and so on and so on. So what we really have to do is we have to figure out where negative 2 fits into these domains. Okay, and negative 2 is in this domain right here, because this is all values of x that are less than or equal to 1, which negative 2 is. So when I'm doing f of negative 2, I'm going to plug in a negative 2 right here, and I'm going to work that out. Okay, so that's where I'm getting that from. So I am going to do 2 times negative 2, and then add 1. And then that's going to give me negative 4 plus 1, which is negative 3. Looking at part B, we're going to do the same thing. So I have to figure out where does negative 1 fit into these domains. And it would still be the same one. So then I am going to do 2 times negative 1 plus 1, which is negative 2 plus 1. And the final answer then would be negative 2 for that one. Oh, I'm sorry. What am I saying? Negative 2. Oh, my fault. Negative 1. Okay. Part C, f of 7. Well, 7's not in here. It's not in here, but it is in here. So I'm going to put 7 right into this spot. So I'm going to do 7 squared plus 3. 7 squared plus 3, which 7 squared is 49, plus 3 will give me 52. And then the last one, f of 3. So I'm going to look for where 3 fits into one of these domains, which would be right in here. So I'm going to put 3 right there. That's a nice easy one, right? I'm going to do 3 plus 2, voila, and it's 5. All right, so if we turn the page and we look at 12 through 19, I just kind of split this up so I have more room on the page to write. Remember when you have a limit and you don't have a picture, it's a little different. So this says as x approaches 3. Well, I can't look at the limit coming from the left or the limit coming from the right because, again, I don't have a picture. So what we always start by doing when we have a basic limit question and it wants you to evaluate it at a certain number, okay, you're going to just plug that number in. And a couple of things are going to happen, and I'll start talking about those as we get further into each question. All right, so the very first step always is going to be to plug the number in, and then we'll go from there. So I've got a negative. Oops, let's make that look a little bit bigger. Negative, and this is an equal sign. We've got a 9 over, and then I'm plugging in 3 for x. So that's simply negative 3. That's your answer. Okay, that's your best case scenario. All right, let's go over to number 13. We're going to do the same thing. Always plug the number in first, and then we can adjust if we need to. All right, there should be a negative in front of there. So I've got 5 minus, I'm plugging in 3, and then I'm in the denominator, I'm doing 3 squared, which is 9, minus 25. All righty, so I've got a negative. In the numerator, I have a 2. In the denominator, I've got a negative 16. All right, hopefully you see that that's a double negative, so I'm going to make that a positive, and I'm going to reduce that at the same time. And I'm just going to put it out here so it makes it a little bit easier. So that's going to be 1/8. There's your answer. Still fine. Everything's fine. Okay, now let's try 14. So I'm going to be plugging in negative 2, right? So I'm going to be doing 2, negative 2 squared is 4, plus 3 times negative 2 minus 2. And then in the denominator, I'm also plugging in negative 2, negative 2 plus 2, which is going to give me 0, right? So let me put a 0 here. Okay, in the numerator, I've got 8 minus 6 minus 2, which gives me an indeterminate. That's what I was trying to cryptically talk about before. So let me backtrack again. If you don't have a picture and you have to find a limit as x approaches some number, plug it in first. If you get a nice answer like these two, no problem. When you don't and you get an indeterminate, now remember an indeterminate means that you have to have a 0 in the numerator and the denominator. If that happens, you're going to go back to the drawing board slightly, factor this, cancel like terms, and then plug in again. So if you're like, wait, what? Okay, I'll show you. I am going to factor that numerator, and you can take a couple minutes, pause me, and factor that. I do it one way, you do it another, but all right, so when I factor that, I get 2x minus 1, and you better know how to do this on your own. And x plus 2. Okay, and that's technically over x plus 2, right? So what I meant was cancel out your common factors. And now what you're left with is this 2x minus 1. What you're going to do is take that remainder, and you're plugging in the negative 2 again. All right? So I'm going to do 2 times negative 2 minus 1. And that ends up being negative 4 minus 1, which is negative 5. And that's your answer. Okay, so again, the deal is that you always plug this number into the original first. If you get an indeterminate, factor, cancel, then plug it in again. Okay, all right. Let's go to the next one, which is number 15. So I'm going to plug in 3. So 3 into the numerator gives me 9. 3 into the denominator is going to give me 3 squared, which is 9, plus 1, which is 10. Now, if we look at number 16, let's look at the bottom half of this page. We're going to do the same exact thing. I'm going to plug in 3 into the numerator, so that's going to be 3 squared, which is 9, minus 9, over then 3 into the denominator, 3 minus 3. So obviously you can see that's one of those indeterminates that I was talking about. Okay, so all you're going to do then is let's factor, cancel, and plug in again. The numerator is the difference of two perfect squares, and the denominator is just that, factored, cancel. Now I'm just going to plug in this 3 into what's left over. 3 plus 3, which is 6. All right, let's do the same thing on 17. So I am just going to plug in a 1. Okay, well, the numerator I can't plug anything in, so I'm just going to write that. And then 1 squared is 1 minus 1. Now let's be careful here. Is this indeterminate? And I hope you're saying no. This is not indeterminate. That is, indeterminate means 0 in both the numerator and the denominator. This is undefined. So your answer to number 17 is undefined. Just please be careful with that one, okay? All right, 18. Now, a little bit of a game changer here because we're not approaching a number like a definitive number. Infinity goes on forever and ever. So when we do these, remember what you're supposed to do is look at what we call end behavior. So you're going to look at the highest power in the numerator, which is the 2x squared. And now the highest power in this denominator here is really x, but we're going to be squaring that, right? So let me rewrite that. So really in the numerator, the highest power would be the 2x squared, and in the denominator it would be just a 1x squared. And remember, we just reduced that, so the answer is 2. All right, now with number 19, we have a higher power in the denominator than we do in the numerator. So now again, please, I'm going to stop myself. These rules that I'm using only apply to limits as x approaches infinity. So when a limit is asked as x approaches infinity, you do end behavior, like we did here, reduce, and that's your answer. But we can't do that here because this isn't like 5x over 2x. If it was 5x over 2x, then my answer would be 5 halves. So when the denominator has the higher power, remember your limit will go to 0. I'm going to repeat that again. When the denominator has the higher power, the limit goes to 0. All right, now let's look at 20. Okay, now same thing. If you look at 20 and you look at 21, those are all limits as x approaches infinity. I'm going to take the highest power in the numerator, which is negative 6x, and I'm going to take the highest power in the denominator, which is 5x cubed, and I'm hoping that you see that the higher power is in the denominator. So just like number 19, this answer then is just going to be 0 because the higher power is in the denominator. Alrighty, let's look at 21. It says x approaches infinity. So I'm going to take the highest power in the numerator, which is x squared, and the highest power in the denominator, which is just x. Okay, now this is really the opposite of 20 if you think about it. Here the higher power is in the denominator. It goes to 0. Here you have a higher power in the numerator. Okay, so when you have a higher power in the numerator, your answer is infinity. Alrighty, so limits as x approaches infinity. Either you're going to get the same power in the numerator and the denominator and you just cancel and you get some kind of number answer like you did in number 19. Okay, wait, hold on. I don't think it was 19. Nope, like you did in 18, my apologies. So if you go back and you look at 18, you had an x squared and an x squared, both in the numerator and the denominator. Those canceled out, the answer was 2. 19 and 20, higher power in the denominator, answer is 0. 21, higher power in the numerator, answer is infinity. Okay? All right, let's go to 22, because now we're back to a number again. So if we're back to a number again, I guess that means we just plug that number in, right? So let's do it. So if I plug in 1 into the top, 1 to the 4th is 1 minus 1. And into the denominator, 1 minus 1. Well, we're back to that indeterminate again, which means we have to factor. Now, just before I go any further, I canceled out 24 because it's the same thing as 22. Okay. So what? I have to factor, right? So that's going to be x squared minus 1 and x squared plus 1. And the denominator I just leave, right? Okay, I can still factor some more though. This is dots, so I'm going to keep going. Oh, but by the way, this is not dots because that's not a minus sign, so don't even think about factoring that. I'm just going to finish this down here. So that's going to go x minus 1, x plus 1, not dots, so x squared plus 1 stays as is, and then the denominator is x minus 1. Cross it out. Now, with whatever you have left over, you are going to plug in this number, which is a 1. So I'm going to be plugging in 1 down here for all those x values, okay? Let me put it down here. So I'm going to get 1 plus 1, and then 1 squared is 1, so that's another 1 plus 1. So essentially 2 times 2, right, which is 4. Okay, let's look at 23. Again, it's not infinity, so I'm just going to plug that 4 into the numerator, which is going to give me 0, and into the denominator, which is also going to give me 0, right? Because 4 squared is 16, 16 minus 16 is 0. Indeterminate, let's factor. So this is very similar to 22. 4 minus x, and then here, now this is 16 minus x squared, so make sure you write 4 minus x, 4 plus x, not the other way around. Don't write x minus 4, x plus 4. 4 minus x, 4 plus x, and those disappear. Okay, now just be a little careful here because at this point, we're kind of like where we were here, right? And at this point, what I did was I just plugged the 1 in. And I'm going to do the same thing. I'm plugging in 4 here, but look, this canceled out. So don't forget that even though there's nothing left in the numerator, technically there is a 1. So this is going to be 1 over, and then 4 plus 4. So my final answer is 1/8. Just be sure not to write 8. Alrighty? Okay, so a couple of things Miss Carter can't count. This is number 22 and 23, and we already had a 22 and 23. Sorry about that. But I wrote in what I wanted you to determine with regards to continuity. So, for example, like 22, I want you to determine if f of x is continuous at x equals 0. So that being the case, this is the limit coming from the left, and this is the limit coming from the right. So I'm just going to use this part of the piecewise function and this one. I'm not using this one for x equals 0, okay? All right, so let's do that. We're going to plug in 0, right? So I'm going to get 3 times 0, which is going to be 0, plus 3, which is really just 3. And then down here, I'm going to put in -2 plus, and that's the square root of 0, which is really 0. So that's -2. Okay. You can determine then that the function f of x is discontinuous at x equals 0 because, now make sure you write the reason because it says justify all answers, because the limit of the function as x approaches 0 from the negative direction does not equal the limit of the function that's an x, as x approaches 0 from the positive direction. That's your reason. We're going to do the same thing for 23, except that I'm looking at x equals -3. So I'm just going to be looking at the top part of the piecewise function and this middle part. We're going to ignore this bottom part. Okay, how about we put in -3 into that top part of the piecewise function? So if I put in -3 here, -3 plus 4 is 1. Squared is 1. And then that final answer will be -2. Let's do the same thing in the middle part. I'm putting in -3, but -3, when I take its absolute value, is a +3 plus 4, which is 7. This should look familiar to what you have right up there on the top with number 22. So you're going to have the function will be discontinuous at x equals -3 because the limit of the function as x approaches -3 from the negative direction doesn't equal the limit of the function as x approaches -3 from the positive direction. Okay, all right, let's go on to the next one. Alrighty, so we're going to turn the page here. Now this one is kind of similar to what we did on the last page in the sense of we're going to be plugging values into the top part of the piecewise function and the bottom part of the piecewise function. But the difference is here is they are telling you that the function is continuous. So you can assume that when I plug in 2, this will be equal to this. That's really what they're telling you to do. And they want you to find that value of a that will make it equal. So in other words, you're going to take the top part of the piecewise function, and it's supposed to equal the bottom part of the piecewise function. And why is that? Because they said it's continuous, and that's the definition of continuity. Now, if you look at the domains, both domains center around this x value of 2. So I'm going to put in a 2 here, and I'm going to put in a 2 here, and then I'm just going to solve for a. All right, so I've got 2a minus 7 equals -6. And when I put in a 2 underneath there, that's just going to be 0. So I can move that 7 over. I'm going to get 2a equals 1. And then I can divide out that 2, so my answer is a equals 1/2. All right, next one, same exact thing. In this case, though, let's see, what can we do? They don't specify as to whether I should look at -2 or whether I should look at 0. So in this case, do you also see, though, that there is an a value and there's a b value? So watch what happens when we do this one. I'm going to start by just using -2. So I'm going to just look at this top part and the middle part, okay? And I'm going to set them equal to each other. And at the same time, I'm going to plug in -2. Why? Because this has a -2 in its domain, and this also involves a -2 as well. Okay, so let's just start by doing that. So if I plug it into the top part of the piecewise function, the -2, -2 if I cube it is -8, right? Then -2 if I square it is 4 times that 9 is 36. And then if I plug in a -2 times that 27, that's going to be -54. Plus 32. And now I'm going to set it equal to the second, or that middle part of the piecewise function. Plugging in a -2 rather, again for a. Well, -2 if I square it is 4, so that's going to be 4a plus b. Okay, now there's a lot of junk going on there on the left, so I'm just going to simplify that all. And when you simplify that all, I get 6 equals 4a plus b. Well, I mean, that's nice that I simplified it, but it doesn't help me find a or b quite yet anyway. So let's go to plan B. Now, by the way, what we did is right, and we do need to use that. But remember, what I did was I just plugged in -2 into the top and the middle. So what I'm going to try doing is plugging in 0 into the middle and the bottom. And that's going to help us quite a bit. Watch what happens. So I'm going to plug in 0 into that middle part of the piecewise function. Okay, so right here. And 0 squared is just 0, isn't it? And 0 times a is just 0. So what's left here is just b once I plug in my 0 for my x value. So all I have there is b. Now what I'm going to do is I'm going to set it equal to this bottom part of the piecewise function when I plug in 0 for x. And when I plug in a 0 here, do you see that becomes 0 minus 5? Which is just -5. Well, look at that. We just found one of the values they wanted us to find. And now that we know that b is equal to -5, can't we take this 6 equals 4a, and now we know that b is -5. So we just plug that in, and now we can solve for a. So I'm going to add that 5 over, which is 11, equals 4a. And then I'm just going to divide out that 4, and there's your a value. You don't need to simplify that anymore. You're done. Okay, so not too bad. All right, let's look at 26. Same thing. As x, we're going to be looking at this and plugging in -3 because that's the number that's associated with both of these domains. So I'm going to plug in a -3 here, and I'm going to plug in a -3 both here and here. And we're going to set them equal to each other because they told us that the functions are continuous. All right, so let's plug in -3 into that top part, and that's going to be -9 plus 8. I'll deal with that in a minute. And we're going to set it equal to a times -3 squared, which is 9. Well, this is going to look really gross. I hate writing it like that. I don't know why I did that. Sorry. And then I'm plugging in a -3 into the 5 times x, so that's going to be -15, and then minus 4. All right, so we got -1 equals 9a minus 20. So I'm going to add 20 to both sides, right? And if I add, what am I doing? Listen to me. That's not 20. That's -19, isn't it? Okay. I'm going to try to salvage that. There we go. -19. So I'm going to add 19 over, which, when I do that, will give me 18. Equals 9a, and a is equal to 2. All right, turn the page. All righty, so I saved the best for last. These are the easy ones, right? Very simple. So all you're going to do in part A is you are going to look at the fact that we have the limit. Now they have a 3. Then we're going to multiply it by whatever the limit as x approaches 1 of f of x is, which we know here is 2. And then we're going to multiply that by the limit as x approaches 1 of whatever h of x is, which is over here, which is 7. If this is x approaches 1, you will always be given something that will also be approaching 1. It's never going to be different numbers, so you don't even have to ever worry about that. Okay, so we basically have 3 times 2 times 7, which is, that's an equal sign, 42. Next. All right, so we've got 2 times the f of x value, which is 2, over the h of x value, which is 7, minus the g of x value, which is 3. So in the numerator, we're going to have 4, and in the denominator, you're going to have 4 also. So your final answer on that one is 1. Alrighty, C. Here we go. We're going to do g of x, which is 3, minus 3 times the f of x value, which is 2, and then we're going to put it over the f of x value, which is 2, but we're going to square that, right? So that's going to be 4. And then we have plus the g of x value, which is 3. Okay, so in the denominator, I have 7. Let me see if I can squeeze that in there, 7. And then in the numerator, I have 3 minus 6, and 3 minus 6 is negative 3. So your final answer is negative 3/7. All right, D, we've got 3 times the f of x value, which is 2, times 2 over the h of x value, which is 7. Now this is all technically over 1 if you want to look at it that way. So we've got 3 times 2, which is 6, times 2, which is 12, all over 7. And E, h of x, well, that's 7 minus f squared, so that would be 4. And then that is all over g of x, which is 3, over h of x, which is 7. Okay, I'm going to go this way. So that's going to give me 3 over 3/7. Now remember, keep, change, flip, because I don't like writing it like that. So we change to multiplication, and then we flip that fraction, which would cancel those guys out. Okay, so that makes your final answer 7. All right, last question. Alrighty, so when we look at this one, same deal. So my f of x value is negative 3. My h of x value is 8, and well, that's it. B, we're going to do 2 times your f of x value. So 2 times my f of x value, which is negative 3, over h of x, which is 8, minus negative 3, which is really 8 plus 3, right? So we've got negative 6 over 11. Okay, and C is the cube root of the h of x value, which is 8. And the cube root of 8 is 2. D, 3 times the f of x value times 2 over the h of x value. And that's technically over 1, and that should be an 8. So we've got 3 times negative 3 times 2, which would be negative 18 over 8. Please don't leave it like that. Simplify that. So that's going to be negative 9 over 4. And the last one, E. We've got the f of x value, which is negative 3, minus 2 times 0, which we know that's going to cancel out, over h of x, which is 8, over f of x, which is negative 3. So let's kind of simplify that a little bit. So in the numerator, we're just going to have negative 3. And then in the denominator, I'm going to have 8 over negative 3. So let's do that keep, change, flip again, because that's ugly. We're going to keep the numerator, which is 3, change to multiplication, flip that bottom fraction. So that's going to become negative 3 over 8. And that's technically over 1. And that's going to be a 9 positive, because you've got 2 negatives there, over 8. And there's your final answer. All right, guys, study hard, please.